Which solution has the highest pH? 0.02 molar LiOH, 0.01 molar CaOH2, 0.03 molar NaOH, or 0.04 molar KOH? The answer is 0.04 molar KOH, potassium hydroxide, because the solution that has the highest pH will be the solution that has the highest concentration of hydroxide ions, OH-. 0.04 moles of potassium hydroxide will release 0.04 moles of OH- ions, more than any of the other solutions can do. At 25 degrees Celsius, a solution has a pH of 7.00. Which statement is true? The solution must be acidic, the solution must be basic, the concentration of H3O plus ions equals the concentration of OH- ions, or the concentration of H3O plus ions plus the concentration of OH- ions equals 1 times 10 to the negative 14. The answer is the concentration of H3O plus ions equals the concentration of OH- ions. Because at 25 degrees Celsius, pH 7 represents a neutral solution in which the concentration of H3O plus ions is the same as the concentration of OH- ions. Which pair of species forms a buffer system? HCl and NaCl, NaOH and NaCl, CH3COOH and CH3COO-, or NH3 and NaCl? The answer is ethanoic acid and ethanoate ions, CH3COOH and CH3COO-, because an acidic buffer system can be formed from a mixture of a weak acid and its conjugate base. Well, the weak acid here would be ethanoic acid and its conjugate base, the ethanoate ion. A weak acid is titrated with a strong base. At the half equivalence point, the concentration of HA is greater than the concentration of A-, the concentration of HA equals the concentration of A-, the concentration of HA is less than the concentration of A-, or the pH equals 7. The answer is the concentration of HA equals the concentration of A-, with HA being the weak acid and A- its conjugate base. Because at the half equivalence point, half of the original moles of HA weak acid will have reacted, and those same moles of weak acid that have reacted will have formed A-. Why does adding a small amount of strong acid not significantly change the pH of a buffer? The acid is neutralized by water, the conjugate base reacts with the added acid, the buffer prevents any reaction, or the acid is diluted. The answer is the conjugate base reacts with the added acid. A- ions accept H plus ions from the strong acid that's added and forms HA. This means H plus ions from the strong acid don't remain free in solution and therefore don't change the pH significantly. The solubility of a salt increases in acidic solution when the salt contains a neutral anion, a conjugate base of a weak acid, a conjugate acid of a weak base, or a metal cation with a positive 1 charge. The answer is a conjugate base of a weak acid, because the acidic solution provides H plus ions that will combine with the conjugate base ions A- to form the weak acid HA. This will shift the equilibrium for the dissolving of the salt in the forward direction to replace the A- ions that have combined with H plus to form HA, meaning more salt will dissolve in the solution. When the pH of a weak acid solution is greater than the pKa of the weak acid, the predominant species is HA, H3O+, A-, or OH-. The answer is A minus, because when the pH is greater than the pKa value, the solution is more basic than the acid's equilibrium point. So more weak acid HA has lost H plus ions, meaning the conjugate base ion concentration of A minus is greater and predominates. For a weak acid HA with a pKa of 4.5, which statement is correct when the solution pH is 3.5? The concentration of A minus is greater than HA. The concentration of HA equals the concentration of A minus. The concentration of HA is greater than the concentration of A minus, or the acid is completely dissociated. The answer is the concentration of HA is greater than A minus. Because remember, when the pH is the same as the pKa of a weak acid, the concentration of HA equals the concentration of A minus. Well, here the pH is lower than the pKa of the weak acid, which means there must be more acid than A minus in the solution, so the concentration of HA is greater than A minus. Now, which statement best explains why HCl is a strong acid in water? The HCl bond is long and weak, allowing partial ionization. Chlorine is highly electronegative, stabilizing the conjugate base. HCl contains an OH group that readily loses a proton. Or hydrogen bonding in HCl increases proton donation. The answer is chlorine is highly electronegative, stabilizing the conjugate base. Because the conjugate base of a strong acid is very stable, which makes it a weak base. Remember, strong acids have weak conjugate bases. A weak acid solution has a pKa of 5.0. What is the value of Ka? 5.0, 1.0 times 10 to the power 5, 1.0 times 10 to the power negative 9, or 1.0 times 10 to the power negative 5. The answer is 1.0 times 10 to the power negative 5. Because remember, the relationship between pKa and Ka is Ka equals 10 to the power minus pKa. An acidic buffer solution must contain which of the following components? A strong acid and a strong base, a weak acid and a strong base, a weak acid and its conjugate base, or a strong acid and its conjugate base. The answer is a weak acid and its conjugate base, with the buffer solution being able to minimize or resist change to pH when acid or base is added based on the equilibrium that's established between the weak acid and its conjugate base in the mixture. Which salt becomes more soluble as pH decreases? NaCl, AgCl, CaCO3, or KNO3? The answer is CaCO3, calcium carbonate. The CO3 2 minus ions in calcium carbonate can accept H plus ions to form hydrogen carbonate ions, HCO3 minus. When they do this, the concentration of CO3 2 minus in the solution decreases, and the equilibrium for the dissolving of the calcium carbonate shifts to the right, the forward direction, and more calcium carbonate can dissolve. If the pH of a buffer is greater than the pKa, which species predominates? HA, H3O plus, A minus, or OH minus? The answer is A minus, because when the pH is equal to pKa, then the concentrations of HA and A minus are the same. However, if the pH is greater than pKa, that means there must be a greater concentration of A minus compared to HA in the mixture. A buffer solution initially has equal concentrations of HA and A minus. If a small amount of strong acid is added, what happens to the ratio of the concentration of A minus compared to the concentration of HA? It remains equal to 1, it increases, it decreases, or it becomes 0. The answer is it decreases. Because as the strong acid is added, it reacts with A minus to form HA. This means the concentration of A minus will go down and the concentration of HA will increase. Well, this means the ratio of A minus to HA then will decrease. Which statement best describes a buffer solution? It prevents any pH change. It neutralizes all added acid or base. It minimizes pH change upon small additions of acid or base. Or it always has a pH of 7. The answer is it minimizes pH change upon small additions of acid or base, with an acidic buffer being a mixture of a weak acid and its conjugate base, and a basic buffer being a mixture of a weak base with its conjugate acid.